So we're essentially today, good morning, Eileen. I'm just going to be, we're going to be working through some more examples of the types of problems that we should be able to do by this point. And so we're going to do a couple of problems and work those out, and I'm going to show you guys what we have planned for the week in Canvas, and what the expectation is with those assignments, because there is going to be one brand new type of assignment this week that is very important. So that's what we're going to do today. I'm going to share my screen. There we go. As usual, if you have questions, you can raise your hand, you can unmute your mic and ask, or you can type into the chat. All of these things will be monitored. So please do let me know if you have a question. Other than that, once again, if you have notes that you're taking, this is now the time to have them ready. And we are going to get started. All right, so, yeah, we do that, this, and blue. So here's our first problem here. The Earth's temperature increases as you move from the surface towards the center. It increases approximately 20 degrees Celsius for each kilometer beneath the Earth's surface. Right, so in this word problem here, we have an increase of 20 degrees for each kilometer. All right, that's probably important. Let's see, we need to complete the table below showing the temperature in Celsius as a function of distance beneath the Earth's surface, kilometers. So we've provided some units that we need to use. Right. Assume the temperature on the surface is 15 degrees Celsius. This is also important. Where do you write this down? If you have somewhere you're taking notes, I would add this to your notes from this current unit. You guys can see what I'm talking about, right? You can see my screen in the example, correct?
Yeah.
Okay. I was worried there for a second. Maybe you couldn't see what I was doing. So it's up to you if you want to write this down, or if you just kind of want to write down main bullet points about what I'm talking about. It's kind of up to you. As always, like, I'm recording the session, you know, so you'll be able to look back at the session, and I'll be posting, you know, like pictures of what we've done into the live class resources that will be available later today. So you'll have access to all the things that we do. I do recommend taking notes because it helps to remember things. It helps you make connections to things. However, like where you want to write this down, that's kind of, it depends on how you're taking notes. I hope that's helpful. I don't know if it's necessarily helpful. So let me ask you guys, we've highlighted two different things within the first few sentences of this problem. Why did we highlight those? Why are they important? Tell me in the chat. What's the stuff I highlighted in green? The first things I highlighted, we have it increases approximately 20 degrees Celsius for each kilometer. What value might that be that it's important to a linear function? I'll type it in the chat too. And this is a question that I'm asking. I just put it in the chat. Why did I highlight that the temperature is increasing? Why is that possibly important? put in the table below. Okay. Right? So the temperature is increasing, so that means like this row needs to be increasing. All right? To know which way we're going. Yeah. So Jocelyn, Eileen, yeah, that's going to help us know, right? It's positive, right? Our temperature should be increasing, right? So that's good to know, right? We have to know that. We have a positive. What have we been calling this thing that's increasing? What's the two different names that we've applied to whether something's increasing or decreasing over time or over distance or over some other value? It's like the vocabulary term that we've been using for that. There are two things that I need to have to write a linear equation or a linear function, two special values that we need. This is one of them that I've highlighted in green, right? That it's increasing 20 degrees Celsius for each kilometer. Which of the two values is this? It's telling me how much something is changing. Yes, yes, thank you, Justin. It is the rate of change, right? Otherwise affectionately known as our slope. Right? So we have a slope here, or rate of change. This other part that I highlighted, assume the temperature on the surface. If I'm on the surface, how far beneath the Earth's surface am I if I'm on the surface? Yes, I mean 0, right? So what is this value right here represent? Yes, Nicholas, 0. So this 15 degrees Celsius, what does it represent? Yes, right, we have y-intercept. Right, and the starting point, yes, perfect. Yes, Jocelyn and Destiny, thank you, right? So we have the start point, or y-intercept. So just in the very beginning here, the first couple sentences of our context here, we have lots of information, and we have all the important information we need to move forward in the problem. Right, so now we have a start point, we have a rate of change, so we should be able to fill in the table. Right. For our first entry here for temperature, we just said this is the start point on the surface, which is at 0 kilometers. Right, so this is going to be 15. And that's just based on this start point. So what should be our next entry in the table at a distance beneath the surface of 3 kilometers? How much, well, let's ask this. How much should I add to 15? Right, to get from here to here, what do I add? Right. I'm going to point back. So Eileen, it's a good guess. But look back at our slope. This is a 20-degree increase for each kilometer. That means per 1 kilometer. Okay, excellent. So Nicholas, I think you did the math already. Eileen, yes, we're adding 60, right? Because we've added 3 kilometers, so we've done our rate of change 3 times. Right, we've gone from here to here. Is it moving? Stop moving. Right, to go from 0 to 3. Why is this moving on me? What is going on here? Oh, that's why. Let's do that. All right, to go from 0 to 3, we added 3. So that means we've done 3 rates of change of 20. So we add 60, which then puts us where Nicholas said, at a value of 75. All right, we add 3 more. Right, go from here to here. And we add the same amount again, right? We're going to go up 60. Come in at 135. Right, we're going to add another 60. Come in at 195. Right, and finish off our table adding another 3 kilometers, 9 to 12, add another 60 degrees, and that puts us at 255. What questions do you have so far? No. Okay. So we've done part A. Hooray! Now we're going to write a rule relating now and next that shows how the temperature changes with each additional kilometer beneath the Earth's surface. So again, I'm going to point out we're doing each additional kilometer here. All right, our table is doing an increase of 3 kilometers. For this rule, how many kilometers am I adding each time for my rate of change here? So I'm just doing each. All right, I'm doing a 20-degree increase on the temperature for 1. All right, we're doing a +1 on the kilometers. The table is doing +3, so we had 3 rates of change, adding 23 times to get 60. So this one we'll use, the other. So now we have next equals now. Plus 20 degrees Celsius, starting at, our start point is still 15 degrees Celsius. In this case, with this written rule, next equals now plus 20 degrees Celsius, starting at 15 degrees Celsius, I am including the units, right, of degrees Celsius, because I can. It makes sense within a written context here. Right. Are there any questions about how we got the now next rule? Okay. So then we'll move on to the next part. Now it's asking us to write a function rule, right, relating temperature T and distance beneath the Earth's surface D. So it's telling us what variables to use, T and D. Right? So we have to use that. It's even started us with the variable here at T. Right? Temperature depends on the distance beneath the Earth's surface. So temperature is like y, if we're doing y equals something x plus a value. So T takes the place of y. D will take the place of x in our equation. Okay. We already know that we have our rate of change of 20 and our start value at 15. So when we write this equation, we're going to have T equals 20 D, because D is replacing X, plus 15. Okay, so the temperature equals 20 times the distance plus 15. And once again, the T is essentially the Y, the D is essentially the X. If we're relating this to X and Y variables that we're more familiar with, right? All right. All right. So part D of this says circle a graph that could be a graph of temperature as a function of distance. So we're trying to find which graph down here, 1, 2, 3, or 4, represents this formula, or this now next rule, or this table. It's going to be the same graph no matter which representation we're looking at. So we have to pick which graph and then explain. Right? Moving from left to right, should we be increasing? Like, should the arrow be going up, or should the arrow be going down? Are we increasing or decreasing? Eileen says up. Anyone else have an idea? Increasing, yes. Destiny says increasing. Okay. So which graphs can we eliminate? Can we say it's definitely not these graphs? Yes, so Jocelyn, yeah, we can eliminate graph 2 because this is a decreasing graph. It's not this one. Right, yeah, graph 2, we can cross it off. It is not graph 2. Right? So that leaves graph 1, 3, and 4. What's wrong with graph 4? Is graph 4 representing a linear function? No, it's okay, Eileen. I know that's what you thought. No worries. What's the issue with graph 4? It curves. Yes, it's not linear. Right? Just in the name a linear function, that's a line. All right, and Nicholas says graph 1 doesn't belong because it starts at 0. Excellent, yeah. So we know this doesn't work because this is not linear. Really, I cannot write. This is not a line. This is decreasing, which doesn't fit. Right? This doesn't work because we're starting at 0. All right, so that leaves only one option, right? Graph 3. Okay, this is the only one that fits all the conditions of our function, right? It's increasing, and it's starting above, slightly higher. It's not starting at 0. It's starting at a higher value. Right? So that's essentially what we can write then as our explanation. We've just kind of reasoned it out by eliminating the others and talking about what it what it's showing us, right? So the explanation is, in graph 3 is increasing and starts at a value greater than 0. This is the only graph that fits our function. It's a simple explanation. It's increasing and starts at a value greater than 0. That's how we were able to pick it. That's the only one that does what our rule says it's supposed to do. Is there anything I can clarify for anyone? Okay. All right. Let's look at our next problem. All right, so now this is a slightly different type of problem. Right? It's something we do have the tools to answer, but we haven't seen a problem quite like this yet. Right? This is a scatter plot. All right, shows the relationship between the number of music videos sold per year and the number of years since 1990. So the first step here says, on a scatter plot, this one here, draw a line that you believe is a good fit for the trend in this data. So it says in the trend, is it generally increasing or is it generally decreasing or is it staying level? If we look at this data, should we have a line that's increasing or decreasing? Yes, Jesse, it's increasing, right? Overall, going from left to right. Yes, Ariana, increasing. Nicholas, yes, increasing, right? Going left to right, this should be going up in value. That's what we would assume if we keep adding more years and more values, we should think that it keeps going up. So when we draw, we're going to essentially just kind of pick 2 points or so, or just kind of pick something that's going to be really close to what this is doing. All right. Now, it's not going to be the easiest thing to do because I'm trying to draw this freehand. We'll see if I can make a line that's somewhat straight that we can use. All right. Close. Not great, but close. So we're just going to use this line. Generally, if we're doing a line that's a good fit or something we would call a best fit line, you'd use a ruler so you get a nice straight line. We just don't have that luxury at the moment, so we'll do what we can. So this is the line. All right. So part B says write a function rule that represents the line you drew in part A. Use n for number of years. Again, so it's telling us what values to use for our variables, what letters, since 1990, and V for the number of music videos sold. Show and explain your work below. So this is where we now have some work to do. We need an equation for this line that I drew. It is not a perfect line. There's not excellent points to use, but we're just going to pick and guess and do the best we can. That's the only thing we can do. Right? So I'm going to pick this point here because it's pretty close to a cross section. I'm going to use this point here. Right? This one is essentially at 516. I'll say this one is at 2, 8. Again, I know that my line isn't perfect on these, but these 2 points are very close to my line, so I'm going to use them. If I had a ruler, I would have been closer to these, but it's okay. So we have points. This I would guess is around 3, but we have a way to kind of solve for that if we need to. Well, we can. All right. So here's what we're going to do. We need to find the slope first. Right? We can do this visually without, doing the whole fraction thing, but so we're going to increase, right? Oh man, I can't draw today. Sorry guys. And we're going to have an increase here and an increase on x. Right? On y, we moved from 8 to 16. Plus 8. On x, we went from 2 to 5. Plus 3. All right, so we have our rate of change, so to say, is going to be the change in y divided by the change in x. It's going to be 8 over 3. That's going to be 2 2/3, or 2.6666 going on. I'm just going to leave it as 8 over 3 for the slope. Right? There's no reason to change it from a perfectly fine fraction like this. So here's our slope. We can use this information to find our y-intercept. Right? I think it's going to be right around 3 based on where my line is. Again, my line's not super straight, so it could be a little off. So we'll do some math. And we're going to pick one of the 2 points. I like picking a point with smaller values because they're easier to work with. And we're going to set up our equation to solve for the value of the y-intercept, or in our y equals mx plus b form, solve for the value of b. And so what that means is I'm going to take this point. This is the one I'm going to use. And I'm going to say, okay, 8 equals 8/3 times 2, because that's, so I have my y value first and my x value in place of x, plus b, which is my y-intercept value. And I'm going to solve for b. All right, 8/3 times 2 is going to be a horrible number. This is going to be 16/3 plus b. And let's see. Then, sorry, I'm running out of room, so I'm moving over to the right here. I'm going to write 8 as a fraction over 3, and that's going to be 24/3. Subtract 16/3. And that will give me the value of b. Right? This means that b equals 24 minus 16. 8/3? All right. So 24 minus 16 is going to be 8. So we end up with 8/3 equals b. So then, here's my rule. Written in the form that they want, this will be V equals 8 over 3 n plus 8 over 3. Which means this point here is at 2 2/3. Okay, so good question, Eileen. So Eileen's asking, how did I get 24 over 3 to replace this 8? All right, so I had to convert 8 into a fraction over 3 so I could subtract the fraction that was also in thirds. To do that, right, if I need 8 to turn into some fraction over another number, I take 8 and I multiply it essentially by 3/3, which is just 1. Right? When I multiply fractions, when I multiply a number by a fraction, right, this first, the number by itself multiplies by the numerator in the fraction. Right, so this is equal to 8 times 3 over 3. 8 times 3, 24 over 3. Okay, and if we were to do 24 divided by 3, we would get 8. Right. Having 8 written that way allows me to subtract 16 over 3. Okay, very good question. All right, so show and explain our work. We have all the work. That counts as our explanation in this case. If we wanted to write it out, we can say I selected 2 points along my line. I used those 2 points to find the slope, and then used the first point to solve for the value of the y-intercept, or to solve for b in the equation, and then we have our equation. All right. All right. Well, and so we've already done part C as well. So that's nice. So part C says identify the slope and y-intercept of the graph for your function rule. Explain what each means in terms of years since 1990 and number of music videos sold. So we know our slope is 8/3. Right? This means what it means in terms of years since 1990 and number of music videos sold. The rate of change here, the slope, right, tells me how many millions of music videos are sold, increasingly each year. How many more are sold? So we can say each year about, and we're going to use now the number version of our fraction, about 2.67, we're rounding it, million more music videos are sold than the previous year. And that's based on our slope, or the rate of change. It says for every 3 years, for every 3 years we would sell 8 million more, but we're trying to do a 1-year increase, so that's 2.67, which is the decimal representation of 8/3. So each year, about 2.67 million more music videos are sold than the previous year. Okay, bye, Nicholas. Thank you for sticking around as long as you could. Then lastly, the y-intercept, which we also found was 8/3. Change color. Right, we have 8/3, or you can say 2.67. So in 1990, the first year represented on our graph here, this represents 1990 at 0, 2.67 million music videos were sold. So this is what it has to do with our context. These numbers have something to do with the actual context we provided to start the problem. This is what they mean. That y-intercept means that at 1990, 2.67 million music videos were sold. And then each year after 1990, another 2.67 million more music videos were sold than the previous year. All right. So then part D is use the line you drew in your rule, or your rule, to estimate the number of music videos that were sold in 2002. All right. As far as our graph goes, where is 2002 on the x-axis? Which number here represents 2002? If this is 1990, yes, Destiny, I will have more. I will have the notes posted later. Yes. All right. So if this represents 1990 at 0, where is 2002? Yes, Eileen, it is 12, right? This right here, this 12 represents the year 2002. All right. I didn't draw my line long enough to get to this year. Let's see, it's probably going to be, as a guess, somewhere around here, probably around like, I don't know, 35 million-ish, as far as somewhere over on the y-axis. So we're going to use our rule, because our graph is unreliable at best because we drew the line by hand and we didn't use a ruler and all that fun stuff, but that's okay. We're not going to stress on that. We have a rule. All right. So we're going to put in 12 in place of x in our rule, or in place of n in our rule. They had us use n. Right? But anyway, that's going to look like this. We have 8/3 times 12 plus 8/3. And we just need to put that in our calculator. So let's see here. Let's actually do this in Desmos. Yeah. So we have 8/3 times 12 plus 8/3. Right, 34.666666. All right, or 34 2/3. We'll round it to 34.67. Right, so this gets me an outcome of 34.67. So the number of music videos sold in 2002 in our equation is 34.67 million. But we have to write that million. It's not just 34.67 videos, it's millions, because that is what our graph represents. These numbers are number of millions of videos. All right. And part E. Can your model be used to make a good estimate for the number of music videos that were sold in 1985? Explain your reasoning. All right, well, if I look at the graph here, right, I know that my y-intercept is 2.67, give or take. If I go back another 5 years, that's more than my rate of change. If I go back 1 year, I hit 0, right? Because I would subtract 2.67 from 2.67, I'm going to hit 0. That would mean that in 1989, I was at 0. So this is probably not a good model for determining the number of music videos sold in 1985 because we can't have negative music videos. All right. So this model would result in a negative number. It is not a good model to make this estimate. Right? There we go. This is not going to work out for 1985. We would get a negative number, and that just doesn't make sense. So, there you go. Any questions, comments, concerns? Okay. This is the same process we can use, right? What we did up here using the graph and the 2 points on the line, and that if we're trying to find the rule for a line, for a linear function, if all I'm given is the graph, right, and I don't know what all the values are, we can use the same strategy if it is actually a line and not a best fit line. So please keep that in mind. Okay. So then, and again, this will be available. I will post this into Canvas. For now, we're going to look at what's coming up in the course. All right. So in our weekly module, we're in week 8. All right, we're in week 8. We are still in unit 3 for linear functions. We've made it through Monday and Tuesday. It is now Wednesday. We're in our live class meeting. We will have the notes from today and the recording posted into the live class resources later on today. Our discussion board for today looks like this. Right? It's about slope and y-intercept. And you're given a context, a table, and a graph. And for each of these representations, you need to find the rate of change and the coordinates of the y-intercept, then write the symbolic rule for that linear function. So we need the rule in the y equals mx plus b form, where m is the slope and b is the y value of the y-intercept. So you're going to use these 3 things and get those rules written by finding the rate of change in y-intercept. Okay. And to put in your reply, you're just going to click into reply and use the text entry box to type in your responses. Okay. I already have the discussion board ready for Friday. That one's got a little bit more to it. Well, not a little bit more, but it's based on this table here. You need to find the rate of change, how much fuel was in the tank at the start of the flight. We are not given that information in the table, so you're going to have to work backwards to get there. You're going to write the now next rule for fuel consumption and write the symbolic rule for the to calculate the amount of fuel remaining after any number of minutes. Essentially, now next rule and y equals mx plus b rule is what we need. Lastly, our weekly assignment. I'm not quite done putting it together. It's almost ready. This will be our first self-assessment. Right, the self-assessments are the highest valued assignments that we have in this course. Right? The self-assessment will consist of 3 parts. Right? The first part is a demonstration of understanding. It will be a problem that you will need to solve. And it will have to do with linear functions. It's very similar to the types of problems that we did today and that we've done previously. Right? You're going to have to find slope, or rate of change. You're going to need to find y-intercept or start value. You may be asked to represent that on a table or make a graph, write the rule. You're definitely going to have to write a rule, right? So you're going to have to put these things, use all the things that we've been talking about over the last 3 weeks to answer that question. The second part of the self-assessment is a reflection on learning. In that part, it is just a short type-in answer about how you felt during the learning that you did during this unit so far. What worked, what didn't work, what would have helped, what you would do differently if you started this unit over again, those types of questions and those types of reflections. It is simply just an honest reflection. Okay, I want to know your thoughts. The last part is where you'll self-assess your level of understanding for this content right now. So this is how well do you understand this material as of today? And this is going to be on a 4-point scale. You will either select a 4, which is essentially that you know this stuff really well and you can explain it to someone else. All right. A 3 is that you get it, but you don't get it quite well enough to explain it that well, but you can definitely do the work. A 2 is I get it, but I still need a little bit of help getting through it. A 1 would be essentially that the only way I can do this is if someone tells me what steps to do. And a 0 is either you're not doing it at all, or you essentially to have a 0, you're not doing it at all. You did nothing. That's a 0. You're not, yeah. So there's this 4-point scale. You need to place yourself on that scale, and then I just look back at your work. Right? I look at the demonstration of understanding, and I take into consideration the work that you've turned in throughout this unit. And I either approve your grade because it matches what you've done, or I don't approve your grade, in which case I will place you on the rubric where I feel you've demonstrated your understanding to be. So that's essentially how this will work. You get to kind of have a say in what your grade is on this assignment. Your work just needs to support that. Right? If you don't do any work and you say you're at a 3, your grade will not be approved. Right? If you do not answer like the demonstration of understanding question, but you do the reflection part and the self-assessment part, your grade is not going to be approved because you didn't show me what you understand. Okay? You have to show me something. Right? Even if you haven't done the other assignments for this unit so far, like since week 5, I think. But you do the self-assessment and you complete the demonstration of understanding and you do it well, there's a chance that your grade will get approved, right? And the grade for this assignment will stick, but you have to do it, okay? Are there any questions? And I will review exactly what this is and what it looks like on Friday once, because I'll finish putting it together today. So in our live class on Friday, I will review what the self-assessment actually looks like and how to complete it in a little bit more detail. Okay. All right. Other than that, that is what we had planned for today. So if you have no other questions, and there's nothing else I can help you with, you are free to go and get ready for your next class. I will see you all on Friday.